Let me do this integral by two methods. This is not a very easy integral. See, method one, the first method, I'm using partial fractions. This 1 over x squared, right? And 1 plus x squared. So you have two fractions. This is a, this is b. And then we can determine a and b. And a equals to 1 and b equals to -1. So let me omit the steps. So it's very easy. So we have two integrals. One is sine square x over x squared dx. The other one is minus sine square x dx 1 plus x squared. So we have two integrals. And the first one we have discussed. We discussed the Dirichlet, which is the same result as Dirichlet pi over 2 for the first one, and the minus integral, this is x squared sine square 1 plus x squared dx. I start with the Feynman's trick. F of a equal to integral sine square ax and 1 plus x squared, right, dx. So we have some initial conditions that f of 0 is a 0, and my target integral is equal to half pi minus f of 1, right? F of 1 will be this. Now then, we continue by taking derivative of a of f with respect to a. That will be equal to integral sine square derivative is a 2 sine cosine, which becomes sine 2ax dx 1 plus x squared. And the chain rule, it times x here. Yeah. Okay, good. Then this one equal to I multiply by x both top and bottom. So times x here and x there. And plus 1 minus 1, which is the same thing, sine 2ax dx. Now we have two integrals. The first integral is equal to this, sine 2ax. This is cancelled out, equal to x. And the second one is minus integral x1 plus x squared sine 2ax dx. Now the first one, the dx, I write d 2ax. Then I must divide by 2a. Okay, this is dx. This is dx. But that one is another Dirichlet integral. This one equal to pi over 2. This is Dirichlet. You sign something, d something over something. Yeah, minus integral whatever left and x 1 plus x squared dx. Very good. Now, when f prime at 0, so when this one is 0, this is 0. So you could do half prime. Very good. Then we take second derivative, which would be, this will be 0. This will be negative. This derivative would be 2, right? 2 cosine 2ax. And because I take a derivative for a, so we have under the x here, right? Yeah, dx x 1 plus x squared. Wow, this one is equal to negative 2 x cancel out, and x cancel out is 1 plus x squared, and sine 2 theta is 1 minus 2 sine square theta, right? Theta is ax. Yeah, dx. Very good. So this one becomes minus 2 integral dx 1 plus x squared plus 4 integral x squared x 1 plus x squared dx. Yeah, this one is arctangent, then equal to half pi times 2 is minus pi plus 4. That's exactly f of a. Exactly f of a. Yeah. So we have a differential equation. F double prime of a minus f of 4 f of a is equal to minus pi. That's a differential equation in second order. Very easy one to solve, right? First to find the homogeneous solution, then find the particular solution. So the f of a equal to f of a equal to fc1 times e to the negative positive a plus c2 e to the negative 2a plus quarter pi. That is my differential equation solution for the solution for this equation. Okay, then I'm using initial conditions. F of 0 is 0. F prime of 0 is half pi. So f of a 0 is 0, which means that 0 is equal to c1 plus c2 plus quarter pi. Now f derivative at a 0 is equal to half pi. So which means that half pi, this derivative is 2c, right? Of a equal to 0. This is a negative 2c2 plus the derivative is 0. Yeah. Okay, from these two, I find that C1 is equal to 0. C2 is equal to minus pi over 4. Well, let's check it. This plus the 0, correct? This is 0. This, yeah, that's correct. So my f of a is found. F of a is equal to negative pi over 4 times e to the negative 2a plus quarter pi. That is my f of a. Okay. My target integral is a half pi minus f of 1. So my target is half pi minus f over 1. Right? That is from beginning. Okay, this is equal to half pi minus f of 1 is minus quarter pi e to the negative 1, negative 2 plus quarter pi. Yeah, so my I equal to it's quarter pi, this plus. So quarter pi 1 plus e to the x. So that is my result for the integral by method 1. Now method 2. Well, method 2 I'm using Newton-Leibniz formula. It says that f of 1 minus f of 0 is equal to integral from 0 to 1 f prime of a dA. Okay? This is a Newton-Leibniz formula, the fundamental theorem of calculus. Now, f of 1 is half pi minus f of 1 is half pi minus I. Half pi minus I. That's f of 1. Minus f of 0, z0, is equal to 0 to 1 f prime. This is my f prime. Okay. The integral sin x 1 plus x squared dx. This is my f of 1. F of a. And f prime of a, sorry. F prime of a. There was x here. There was x here. There was x here. I rewrite again. This one equal to integral from 0 to 1, then f prime of a, which is equal to this one. F prime is x sine 2ax dx 1 plus x, then dA. So this is double integral. Yeah. Okay, then we continue from here. Well, this one equal to, I switch the order of the integral, right? I do a first, And this one, x sine 2ax 1 plus x squared. Now this 2x, 2a, I'll do a first. 2a, I write 2ax. So I must divide it by 2x, right? So this is this is dA. This is dA, right? I switch this of to a first, then x. Yeah, so x is cancel. This is uh, this one. Well, let me see. Two. I take it two out. I take two outside. No. Ah, 1/2. Huh? Take two out is the denominator. X cancel out, right? This is 1 plus x squared. X cancel out. This integral is negative, right? Cosine 2ax from 0 to 1. Yeah, then dx. Very good. Okay, sine integral of sine is negative cosine. 2 is taken out. X cancel out. Sine something, sine theta d theta is a negative cosine theta. Yeah, from 0 to 1. A. So this one equal to minus half. Well, minus half. There's two integrals. The first one is a cosine 2x 1 plus x squared from 0 to infinity with the first one minus integral 1 plus dx. Yeah, that's correct. Minus half. Now this one, I have a video prepared for today's integral. The result is pi 2p squared, right? You can see you can go see the result. See, the link is below the under the video, okay, particularly for this integral. And that one is half pi. Yeah. So this becomes take negative 4, yeah. Negative, take negative out, yes. So this one equal to quarter pi minus pi over 4 e to the square, right? So that one is, this side is equal to half pi minus I. So we're looking for I, right? So I is equal to what? Uh, I is equal to negative. Now let me write on the paper. So this this side is a half pi minus I. This side is equal to quarter pi minus pi over 4e squared. Now we're looking for I, right? I is equal to I minus quarter pi negative plus, right? Wait, minus this. She's very clear. I is equal to half pi minus this plus this, right? Yeah. Yeah, I move there. This one, yeah. So this is equal to quarter pi 1 plus 1 e square. Yeah. So we get the same result. So I is equal to quarter pi 1 plus 1 over e square. So we get the same result. This side, simplify, get this one. But we get, while I'm using Newton's Leibniz formula, so this is a totally different method.